Refrigerator is a device which is commonly used in our day-to-day life. We all know that refrigerator is something or a device that keeps a low temperature body or a device or a space at that low temperature. So when I say a refrigerator, what it does is it keeps a low temperature space at that low temperature. This is the fundamental thing that a refrigerator does. Now I'm coming to this block diagram where you know that we always have a source and a sink, where source is the high temperature which is denoted by T1 and sink is the low temperature which is denoted by T2. Always, as I say again, high temperature is the source which is T1 and low temperature is the sink which is denoted by T2. I am installing a refrigerator in this particular scenario. Now, if you look at the definition, refrigerator keep a low temperature space at that low temperature. That means our focus is going to be on the sink because sink is at the low temperature. Suppose the sink is at -5 degrees centigrade. Now that means I want to keep this sink or this low temperature space at that low temperature. And you know that whenever there is a low temperature, the heat from the high temperature will be trying to gain that particular space. For example, when there is any amount of heat that is leaking into the space, for example, say Q2 amount of heat is coming inside the space and changing and trying to change or increase this temperature. So what does the refrigerator do? The refrigerator has to absorb this heat from the low temperature space. So the refrigerator, what it has to do or what it is desired to do, it has to absorb or it has to extract the heat from the low temperature space. So this is the basic desired output of a refrigerator. Whatever heat leaks into this low temperature space, that has to be extracted by the refrigerator. But as we know, the closure statement says that heat can only transfer from a high temperature to a low temperature. Heat cannot travel on its own from a low temperature to a high temperature unless you give them or unless you give it an external work. Therefore, the refrigerator requires an external work. It requires an external work. So I am going to give work over here, which is the input to the refrigerator. That is why in your house, the fridge that you use, you plug it to the electricity so that the compressor will get some work, because unless you give work, the refrigerator cannot extract the heat from the low temperature space. Now, in order to complete the second law or in order to satisfy the second law, it has to reject the heat to the surrounding. Let Q1 amount of heat is rejected to the surroundings. If you see that your refrigerator at home will be having a condenser side, that is the body side, which will be rejecting the heat to the atmosphere. So this is how a refrigerator works. I'm again saying the refrigerator absorbs whatever heat is leaked into this low temperature space with the help of some work, and to satisfy the second law, it will be rejecting the heat to the surroundings or to the high temperature. Now, normally we use efficiency. For the heat engine, we have used efficiency. And normally the value of efficiency will be in the range of 0 to 1, or we say that 0% to 100%. But in case of a refrigerator, when I use the equation efficiency equal to desired output by a required input, since this is a reverse device, okay, since this is a reverse device, what happens is that the efficiency value in case of a refrigerator can go greater than 0. It can go greater than 0. Therefore, I am going to introduce a new term which is called the coefficient of performance, or in short form we use COP. Now COP is exactly same as the efficiency. The only thing is that when I use the term efficiency, I normally think, or I normally believe, that it can go only up to 100%. So we are going to use an index called coefficient of performance that will be denoting the efficiency of the refrigerator. So the equation of COP, it's the same as efficiency, that is desired output by the required input. Now this is a interview question. It can come in an interview where they ask you what is the difference between the efficiency and COP. Effectively, or it's basically the same, but since efficiency value has a maximum limit of 100%, and since COP can go beyond the range of 1, we use the term COP. So here the desired output, what is the desired output here? The only desired output from a refrigerator is that it extract the heat from the low temperature space. That means extracting Q2 is the desired output. Now to extract this output, it requires an input which is the work done. Q1 has no significance in terms of its efficiency or COP, but unless Q1 is rejected to the surrounding, you will never have an engine, because it cannot satisfy the second law of thermodynamics. Now I'll write COP is equal to desired output is Q2 by work done is W. Again we know that the work done is equal to what? It is equal to Q1 minus Q2. Therefore I can write this equation as Q2 by Q1 minus Q2. This is again another possibility, and this can be used to find out the COP of a refrigerator. Again, I can write this in terms of temperature. It can be written as T2 by T1 minus T2, considering this as a reversible refrigerator.